design brief is for a 1,500 pupil strong multinational all-through school with extensive community elements including PE spaces, halls, a pool and a learning resource centre. One of the key points for the brief is for the development to reduce carbon associated with it. This is both in terms of embodied energy within the building but also operational energy across the building's life. And finally, the development is also to be designed to meet the Passive House standard. The site for the development is a greenfield site in North Bristol, approximately 100,000 square metres. The site is surrounded by residential developments, although as none of these buildings exceed 2 stories, there are minimal obstructions. The site is in a central location, so there aren't likely to be any issues with gas and electricity supply, and access to the site is possible from either the east or the west of the site.
Noise levels around the site are relatively low, with audible traffic noise from Filton Avenue and Muller Road to the west of the site. Because of the distance from these roads and the screening provided by the surrounding housing, noise levels are below 50 dB and thereby suitable for natural ventilation. Passive House also requires an internal noise level of 25 dBA from all MVHR units, which is 10 dB below the standard internal noise levels for school. Therefore, there will be no issues in regards to excessive internal noise levels from noise break-in or from mechanical ventilation.
Our concept has been based on a circle such that we can focus the building around a central heart space that all elements of the building will be associated with. We've simplified this to a hexagon to aid buildability and have divided the space up across the primary, secondary and community elements. As a number of the community elements are to be used independently of the school, we decided to have the sports complex as a separate building.
Instead of stacking classrooms immediately on top of one another, we chose to offset and rotate them by 90 degrees, allowing daylight to penetrate deep into each space, reducing the requirement for artificial lighting. Rather than using traditional corridors, we opted for a multi-purpose atrium which also facilitates cross-flow and passive stack ventilation, thus removing the need for mechanical cooling.
We have chosen to use cross-laminated timber for the structure and fabric of the school buildings. Having carried out a comparison of the identical steel frame structure, we've predicted that it's possible to improve the embodied energy by up to 280 kilograms of CO2 per square metre. As cross-laminated timber is typically provided in large panels, this also provides good air tightness and thereby helps achieve the Passive House target of 0.6 air changes per hour.
For the facade build-up, we've allowed for a 500mm zone at this stage. As we have a CLT structure, we've opted for an externally clad building. This allows us to continue our insulation around junctions to ensure our design remains free of thermal bridges. And finally, internally to the CLT, we have allowed for a services void. We've included this to minimise penetrations through the CLT, which could compromise the airtightness of the building.
Passive House stipulates a maximum primary energy demand of 120 kilowatt hours per metre squared per year. This poses difficulties in most buildings, however, for a school with a large swimming pool, meeting this target is even more challenging. The swimming pool and associated shower facilities will have an extremely high hot water demand compared to elsewhere within the school. Therefore, as designers, we have to go above and beyond conventional methods to meet this demand while satisfying the Passive House energy efficiency requirements. Our solution is to install a ground source heat pump system with vertical boreholes buried beneath the school, combined with a biogas CHP system. This will provide secure, low-carbon heat, hot water and electricity to the site. Any waste heat from the swimming pool will be diverted through the vertical ground loops before being drained. This allows heat to be stored seasonally, ready for use when the building needs it.
By combining these design strategies, we aim to create a cohesive learning environment that promotes health and well-being, whilst providing a truly sustainable building that will hopefully become a landmark of the local community.